The last thing right here is that there are some special domains that are more complicated, and so we have to look at those in particular. First, if you have an absolute value sign, simply ignore the absolute value sign. F of x is equal to the absolute value of x plus 3 right here. This will have the same domain as f of x equaling x plus 3, which is all real numbers. Because this right here is a polynomial function. On the other hand, if I have f of x equals 5 divided by the absolute value of x plus 3, then this will be considered the same as f of x being equals to 5 over x plus 3. And in this case right here, the domain is that x cannot equal negative 3. If you set the denominator equal to negative 3 and solve, you'll get that x cannot be negative 3. Of course, that is x such that x cannot be negative 3, or in interval notation, negative infinity to negative 3, union negative 3 to infinity. Right. So that's the first piece of the puzzle right there. The next piece of the puzzle is when you have a combination of a fraction and a radical. So let's say I have my next example, f of x is equals to 7 divided by the square root of x plus 2. Well, what you do right here to find the domain is you actually have to do both things. You have to work it as if it was a fraction, and you have to work it as if it was a radical, and then you combine the two answers together. So if this was a fraction, the domain would be that the denominator cannot be 0. You square both sides, and when you square both sides, you get that x plus 2 cannot be 0. It's actually pretty straightforward. X cannot be 2. If it was a radical, what you would have is you take what's underneath the radical, x plus 2, and you set that greater than or equal to 0. We add the 2, subtract 2. Oh, that means over here wrong. This should be negative 2 when you subtract the 2 from both sides. And so that gives us that x is greater than or equal to negative 2. So how do I combine these two things together? Well, to combine them, they must be both true at the same time. So if x is greater than or equal to 2, but x cannot be 2, when you combine them together, what you will get is simply that x is greater than negative 2. Very simply, the fact that x cannot be equal to negative 2 overrides this negative and causes it to get thrown out. And so therefore, your domain is simply x cannot be, x is greater than negative 2. And of course, x such that x is greater than negative 2, curly bracket. I have my number line. Somewhere in my number line is a negative 2. I have an open circle, and of course I shade greater than above that circle. And I have one interval, and so my interval notation will be open parentheses negative 2 to infinity. Again, you use parentheses when you have an open circle. You use a square bracket when you have a closed circle. The next interesting one, and maybe one of the hardest ones to get, is when you have a fraction two divided by x squared plus 4, but the denominator doesn't factor. What do I mean? Well, the denominator gives us something that's strange or different. In fact, the denominator will not be able to be equal to 0. Again, I said the denominator not equal to 0. And x squared plus 4 doesn't factor. I hope you remember that a difference of squares factors, but a sum of squares does not factor. It's prime. But if I try to solve this, subtract 4, you get that x squared cannot be negative 4. And if I take the square root, and if I take the square root, you get that you cannot take the square root of a negative number. So no real number. So, if there is no number that x does not equal, where am I going? Way back, way back, way back, way back. There you go. So right here, x does not equal a number. It shows up on the number line. If there is no number that x does not equal, then nothing shows up on the number line. Another way of saying this is that there are no restrictions. And so, if I have my number line and there are no restrictions, it means that I'm going to have to shade the entire number line. If I have to shade the entire number line, it means that the answer is, keep doing that, it means the answer in set builder notation is x such that you have your all reals. There is no time this function divides by 0. Gets no answer. There is no time this function divides by 0. So therefore it's all reals. And of course that means you shade the entire number line. And of course that means in interval notation, negative infinity to positive infinity, all real numbers. Alright?